Hello, students. I hope your preparation is going well. We are still in the first unit, that is biomolecules. Today, we are delving a bit into the biophysics side of the things. And today's question is the energy of hydrogen bonds inside the DNA. So, this is the proper question. A canonical Watson-Crick GC base pair is stabilized by three hydrogen bonds formed between a donor carrying a charge of 0.25 electrons and an acceptor carrying a charge of negative 0.35 electrons atom located at a distance of 2.9 angstroms. Assume that the dielectric constant in the DNA core is 4 and in water is 78.5. Which one of the following options correctly represents the total difference in electrostatic interaction energy for all three hydrogen bonds when buried in the DNA core versus fully exposed to the solvent? Now, we have to use the modified Coulomb's constant K, that is equal to 1389 kilojoule per mole nanometer per E square. Now, our options are: first, minus 298.3 kilojoule per mole; second, minus 104.7 kilojoule per mole; third, minus 99.4 kilojoule per mole; and fourth, minus 5.338 kilojoule per mole. Now, this is the equation for the electrostatic interaction energy, where U is the energy, K is the Coulomb's constant, which is mentioned in the question. QA and QB are the charges for which we need to calculate the interaction energy. The charges in our case are 0.25 electron and negative 0.35 electron. Then the dielectric constant, which is for water, it is 78.5, and for DNA, it is given as 4. And ultimately, the distance, which is given as 2.9 angstroms, but since our Coulomb's constant has the units of nanometer, so we have converted this into nanometer, which comes to 0.29 nanometer. Now, we'll put all of these numbers into the equation, and first we'll solve for the DNA core. So, when we put all the numbers into the equation and solve it, then first we'll get energy for a single hydrogen bond, which is minus 104.77 kilojoule per mole. And to calculate the energy for three bonds, we simply multiply it by 3, giving us the number minus 314.32 kilojoules per mole. Now we'll repeat the same thing, but for water. So the only thing changing will be the dielectric constant, which will be 78.5 instead of 4. And the calculation will go like this. Now, in case of water, the energy for a single hydrogen bond will be minus 5.34 kilojoules per mole, and energy for three hydrogen bonds will be minus 16.02 kilojoules per mole. Now, the question has asked us to calculate the difference between these two energies. So, the difference between the hydrogen bond energies at the DNA core and when they are exposed to the water will be, according to the numbers, minus 298.1 kilojoule per mole. Now, if we go back to the question, we can see that the closest is option 1. So, in this case, our correct answer is option 1, minus 298.3 kilojoule per mole. Now, look at this line very carefully. This tells us the sequence of the numbers, because if we flip it and we start with the energy when exposed to water and take the energy at the DNA core as a second, we'll get a different answer. So, when calculating the difference between two numbers, the question has already given us the sequence. Another thing to look at here is that in the options they have given the second option, which is the energy of single hydrogen bond at the DNA core. and option 4, that is the energy of single hydrogen bond when exposed to water. And also the third option is the difference of these two, which will come to around 99.4. So if you are rushing the question and if you forget to calculate for three hydrogen bonds, as the question has asked, and instead if you just rush with the energies of one hydrogen bond, then still according to you, you'll get a correct answer that will be option 3. But in reality, that answer would be wrong because the question has asked for the energy of three hydrogen bonds. So these type of tactics are common in net questions to confuse students. So always read question very carefully and do a double take if it seems suspicious. And similar kind of question can be asked for another base pairs like A and T, or to change this question, the distance between the base pairs can be changed, which can be true for different forms of DNA like A, B, and Z. Now, keep following my channel to learn more such questions. Thank you.